Hello guys, welcome back to our channel, and today we'll be working on a question which is called selection sort. And so the worst case complexity for this is order of n square. So basically we are given an array, so let's take an array 4 3 2 1, so which is an unsorted array. So we need to get an output which will be 1 2 3 4, which is a sorted array. Now we need to use a selection sort. So what's the difference between the selection sort as compared to other sorting algorithms? So let's see. So basically we have an array which is unsorted, so let's take 4 3 2 1, the same array which we had earlier. And in this sorting algorithm we'll start with the zero indexing. So this is our indexing, so length of an array is 4, so we'll start with 0 indexing, 0 1 2 3, the last index will be 3. And then we'll start with the first element. So the first element is 4. Now we need to find the smallest element on the right of the 0th index, so from 0 till here, which is the most smallest element. So in this case the smallest element is 1, so we will be just replacing the value. So it will become 1 3 2 4. This is our first iteration. So we got the first iteration. Now we'll increment our value to 1. So previously we were working on 0 value, now we are on the first index. So let's make it properly, and we are on the first index. Now on the right hand side of the first index, which is the most smallest element? So this most smallest element is 2, this one. So we'll just swap the element. So we'll just swap this, so it will become 1 2 3 4. Great. Now again we were on the second index. Here we'll increment the value. We are here now, and 0 1 2 3, you can see we are on the second index. And then we'll again find the right hand side of the array, which is the smallest element. So here we don't have any smallest element, so 3 itself is the smallest element, so we'll keep it as it is. And then we are at the last index, and it does not have anything they don't have the next index, so it is the last element of the array. So the output will be 1 2 3 and 4. So this is how the selection sort works. This is the simplest way I made you understand. So basically you need to just see all the elements on the right side of the index, and then get the smallest element and swap it. Simple. So let's see how will it work. So first of all we need 2 loops, because one will be on the 0th index, and second will be which will be continuously running to n till n for finding the smallest number on the right hand side of the array. So first let's take, we have an array which was 4 3 2 1, and then we'll take the length of this array. We can take it as n. Let's make it little easy. Let's keep it as n, and it will be length. I'm using Python. Great. Length, and then we can find as array. Now we'll run a for loop for x in range 0 to n minus 1. So we'll go from 0 to n minus 1. So let me show you how. So 4 3 2 1, we'll go till here, because the another loop which we will be running, it will compare these two values. So we'll be like accessing a value, we'll be accessing an index which will be one step ahead in an array. So if we are here, and our second loop will try to access this area, and we don't have any values over here because this is the last element. So we'll run till n minus 1. Now it's time, let's skip minimum is equal to x. So let's keep this index 0 1 2. So let's keep this index as a minimum till right now. Let's keep this index as a minimum index till now. For y, in range will go from x plus 1 to n. So this will go, let me write it over here for better. Okay, 3210. So our x is here and y will be here, and x and y, our x will go till here but y will go till here. Okay, so let's move forward, and then we will be having okay, so now we will be comparing the values. If array of minimum is greater than array of y, then we'll put minimum is equal to y. So what I have done over here, let me explain it over here. 4 3 2 1 0. Our x is here, y is here. Basically our x is also known as right now minimum. So we'll compare array of minimum if it's greater array of y. So right now array of minimum, which is x, which is 4, and array of y is equal to 3. If it's greater, then we'll just update minimum is equal to y. Y is basically the 1 index, so minimum will be 1. Now like this we will be going till end of the loop, and then we'll find the most we'll find the smallest element in the whole array using the indexing. Once we get out of this loop, the secondary loop, we'll just swap the values. So we'll just swap array of x, array of minimum. So array of x will be array of minimum, and array of minimum will be array of x. And then at last, when the whole array gets over, this array till here gets over, will return array. So it's very simple. So once we find the most smallest element on the right side of an array, we'll just put minimum to that value. So in this case, let's take minimum is 0 1 2 3 4. So 4, and then it will be replaced with the first iteration will be 4 and 0. So it will become 0 3 2 1 4. The second iteration, it will again start with here with 3, the most smallest element from this is x1 and this is y, and then they'll start from here and we'll find the most smallest element on the right hand side, which is 2. So we'll just replace this 2, x and y, 2 3 1 4. Sorry, I made a mistake, no worries. Yeah, so smallest element was 1. So smallest element is 1, so it will be 0 1 2 3 4. Yeah, sometimes it happens, guys. So we just replace this with the smallest element, this over here, and that's it. And let's get started. So this is a selection sort question. We already discussed how selection sort algorithm works, and let's try to run this code. So before running this code, I just implemented edge cases. If array's length is 0 or less than 0, we should return -1. So it's a good practicing. And if not, if it's greater than 0, so we'll just run our program. Just we need to find our minimum element from the whole array, and then we'll be swapping the x values, I mean the initial array, with the minimum element, and then we'll just return array. So let's try to run and passes all the test cases, and most probably it will pass everything. So yeah, so we have passes all the test cases. So the runtime is 2 to 3 milliseconds. Yes, this is not the optimal way. You can even optimize it more further. It's totally up to you. So guys, this is for everyone, so that everyone can easily understand what is this algorithm is. So thank you guys, thank you so much.